Hello friends, welcome you all to this live session on ISA MOOC, Introduction to Statistical Analysis, MOOC, which is you are in 4th week, and I welcome you and believe that you are enjoying this course. And with us today, your lead instructor, Dr. Manoj Das, and he will speak before you on week 4 problems and reflection questions, as well as he will also discuss about your queries. And I'm here, Dr. Manas Ranjan Panigrahi. I will also help you to understand your certification as well as anything, your query relating to the course and its structure, and further feedback if you need. With these words, now I would like to welcome Dr. Manoj Das and request Dr. Das, please take up the session. And I wish all our other colleagues also, very soon they will join us in this live session. And we will, next 2 hours, we will discuss in length. And today we will have also open discussion forum where you can speak more about the certification, its criteria, your assignment, along with reflection questions. Over to Dr. Das.
Thank you, Dr. Manas. Am I audible?
Absolutely, sir.
Thank you. Welcome to all the participants to the 4th live session. So, as Dr. Manas has already told you, the session is about questions of week 3 and its solutions. Before going to these questions, that is, check your progress 2 questions and another 9 questions, reflection questions, we'll discuss at length detail about what exactly the problem and how to start the problem, and in what way we will be able to make a quality analysis and interpretation of the result. So before going to start that one, I would like to request Dr. Manas to kindly give a brief about the certification and about the participants, those who have already completed their quiz 1, quiz 2, quiz 3, and many are there in the way are yet to complete the quiz 1 and quiz 2. And I would request many of the participants, they should retake the quiz where there is a provision what to do, how to do, so that they can improve their performance. At the same time, the profile is also important. I would like to request Dr. Manas to kindly give a brief about it so that they will get an idea. It will help them to complete their requisites in support of the certification, because we are at the end of we are at the 4th week. So towards the end of this course, so it is very essential, high time for them to complete the minimum requirement to get their certification. So over to Dr. Manas about the basic minimum criteria and requirement and the part of the.
Thank you very much, Dr. Das. First of all, I like to request participants, and very few participants still joined, only 21, including myself and Dr. Das. And anyway, we can also discuss in the forum all relating to the criteria and everything which is available in your platform. However, I am taking you to understand that the criteria are very simple, that the entire teaching learning process is required for your certification. First is you have to watch all the videos which is available in your platform, and you need to download text content which is available in your platform. Each week, few videos and 1 text module is there. All the videos you need to complete, and you need to download your text content for your reading purpose. And when you will complete all these things, it will show in your profile section about that you have completed, and length of completion and quantum of completion, which will be shown there. Every week you have one quiz comprising of 10 MCQs, and you need to complete the quiz, and minimum criteria for the completion of quiz is 50% and 60%. 50% it is if you will complete in all quizzes, each quiz comprising 50%, you will get your participation certificate. And if you will secure 60% in each quiz for all the 4 quizzes, then you will get your completion certificate. But for this completion certificate also, you need to submit your assignment, and assignment need to be reviewed and assessed by the mentors as well as instructors. Then if you are qualifying, then you will receive your completion certificate. So these are the very simple criteria which you need to complete. Also, along with these 2 certificates, you need to also participate in at least 3 forums, either creating a forum or replying to a forum. So 3 forums, it is a basic criteria which will make us understand that you are participating in the course. So 3 forums participation, which is another requirement for earning of both the certificates. I hope you understand this one, and I would like to request kindly visit to the course platform where you can see the week 0, and you will find entire criteria for the certification, which is mentioned in clear language, which you can follow systematically. And if you are lagging behind, check your progress. And if you are lagging behind, you have opportunity to complete your target and to make yourself to become a participation certificate holder and completion certificate holder for this MOOC. Thank you very much. Over to Dr. Das.
Thank you, Dr. Manas. Now, I hope all of you have got a clear idea and a clear direction, the way to achieve the certificate, that is maybe a certificate of participation or a certificate of completion. So the minimum criteria is very important. Each and everyone is required to reach at the minimum criteria. So make sure from the profile page that you have reached at the minimum level of obtaining the certificate. So thank you very much, Dr. Manas. Now let us come to the week 4, that is, sorry, week 3 different questions. So if you have gone through that week 3, you will find that this is part of the test of hypothesis. The week 3 is about test of hypothesis. See, this week 3 content is very important. So far, what we have completed in week 1 and week 2. These are the basic introductory part. The week 3 part is little bit important with respect to the problems you have identified, or the problem you have been doing, or the research work in which you have been involved, or the research article if you are writing. In those areas, it will be very helpful. So see that technically, statistically, how to make your research work very qualitative, very productive, very meaningful, so that you will be able to contribute to the system. You will be able to contribute to the area of your discipline, your area of your interest in a better way. Because scientific procedure, systematic process, logical thinking is very important in making the analysis and interpretation of the result. Again and again, I am saying solving the problem is important, but it is as important as making the analysis and interpretation of the result. Making a qualitative analysis and interpretation will certainly enhance your qualitative of the research work, quality of the product. So our main important focus is to how to make our research work more productive, more meaningful, and more meaningful from the point of view of the purpose for which it is being planned. So the examples and the illustrations that are given in the module, certainly they are from different areas, different disciplines. These are where we have taken an attempt to give you the real life examples, where you can say that, yes, these are the different areas we are intended to use the statistics. We are intended to apply the statistics. So the application of the statistics, use of the result, making use of the result in a meaningful way are some of the important prerequisites of this course. Now, let us come to the first question. If you look into the first question of week 3, that is the check your progress. So, let me show you the question. I request Dr. Manas kindly allow me to share the slide, please. If you look into that one,
yes,
you will see that
one
the
minute
question
only.
is about a sample of 100 students of standard 12 drawn from a population for an achievement test. Okay. Achievement test. The is found to have average 180. Average
Now you
is
can
180.
share.
Test
Now you
at
can share.
0.01 level of significance, that the sample is drawn from a population whose average is 190.
Dr.
And
Das, you can
standard
able to
deviation is
share.
22. So this is what is the question. If you look into that, see, yes, let me share the screen so that you get an idea. Our question is, see, sample mean is given. Okay. Yes, this is what is the question. Did you get the question? Slide? Dr. Manas, is it visible?
Yes, sir, visible.
Yes, it is visible. Please.
Is it visible? Yeah, no.
Absolutely, absolutely visible.
Fine.
Absolutely visible, Dr. Das.
Yeah. Okay, fine. Second one.
Yes, yes.
Yeah, thank you. See. Now see, if you look into the question and see from the question what exactly the question is given. Looking at the statistical question, because the question is framed based on the title of the study. Based on the one, taking into consideration of one of the objective of the study. So if you look into it, the sample size is given. The sample size is 100. Just analyze the question. On the basis of analysis, you will get that a sample of 100 students means sample size is 100. Mean of the sample is 180. That is clearly given in the question. This is the mean. And the mean of the population is also given, 190. The population mean is 190. Standard deviation is 23. So if you look into it, you will find that 4 different things are given. Sample size, mean of the sample, mean of the population, and standard deviation. Based on these 3, what exactly we have to do? What we have to do? We have to find whether there is a significant difference between the sample mean and population mean. The sample mean is 180, population mean is 190. Population mean is 190. Yes, there is a difference of 10. If the question will be asked to you, is there a difference between the sample mean and the population mean? Yes, there is a difference. But the thing is that, is this difference is significant? Because we are taking into consideration, we are looking into this difference from the statistical point of view, from the research point of view, from the investigation point of view. So with the statistical analysis, with systematic procedure, we have to identify, we have to assess, we have to make an estimate that whether the difference 10 is significant or not. If it is significant, we can say that yes, the difference is significant and the difference is in favor of a population mean, not in favor of the sample mean. If the difference is not significant, we can say that there is no significant difference between the sample mean and the population mean. So this is what we are intended to test on the basis of using a hypothesis. So the question is about this one. Based on that one, as we know, as we are going to take the help of a hypothesis. So how to frame the null hypothesis? For this question, what is the null hypothesis? Null hypothesis is that null hypothesis states that mean of the sample is equal to mean of the population. 190 is the population mean. 190 is our population mean. So mean of the sample is equal to mean of the population. Means if in the statement form I will write that there is no significant difference between the sample mean and the population mean. Null hypothesis. And what is the alternate hypothesis? The alternate hypothesis states that the mean of the sample is not equal to the mean of the population. The mean of the sample is not equal to the mean of the population. This is what is one null hypothesis, one alternate hypothesis. Now, with the help of statistical calculation, we are going to prove whether we are going to reject the null hypothesis or we are going to retain the null hypothesis. If we reject the null hypothesis, we will make the interpretation accordingly. If we retain the null hypothesis, we will make the interpretation accordingly. Now, let's see what will be the solution. See. First, we need to find out the standard error of mean. Based on the question that is given to you, immediately we have to find out the standard error of mean. Standard error of mean is standard deviation by root over of n. Both the values are given. If we put, we will get standard error of mean is 2.3. Simple calculation, direct put the formula, get the answer. We have used our formula and we got the answer. Standard deviation by root over of n. N is the sample size, which is coming 2.3. Now, find out the Z value. Why Z value? Because the sample size is 100, the large sample. As it is a large sample, we need to find out the Z value. Z value is what? The D by SEM. This is what is the D. D means what? Difference between the sample mean and population mean. But here we need to remember that this is the mod D. Mod D means whether it is a positive or negative, it has no significance. We have to take the positive. Even if it is positive, we will take the positive difference. Even if it is the negative, we will take the positive difference. So always we find mod D, that is, mod means the modulus. Modulus of a sample mean minus population mean by standard error of mean. Already standard error of mean is known to us. Sample size mean is given, population mean is given. So just put the formula, you will get the value that 180 minus 190 by 2.3, which is coming minus 4.34. Even though it is coming minus 4.34, what I told in the beginning, it is modulus of D, mod D. The difference is not simple D, it is modulus of D. Means the negative sign is ignored. We don't take the negative value. So what is the calculated value of Z? The calculated value is 4.34. I hope this calculation is very clear to you. If there is any doubt, any confusion in this calculation, kindly you can raise the hand so that we will discuss that. So the calculated value is 4.34. Then based on the calculated value, what is the critical value? The critical value at 0.01, 99% significance level, or at 0.01 probability level. So critical value at 0.01 is 2.58. So in front of us, the calculated Z value is need to be compared with the critical value. Simple logic. The calculated value need to be compared with the critical value. So if we compare this one, what you are going to get? The calculated value is 4.34. The critical value is 2.58. So simply we can say that the calculated value, calculated Z standard value is greater than that of the critical value. So based on the questions that is given, based on the statistics that are there, statistics means measure of the sample. Based on the measure of the sample what we got, we find that the calculated value is greater than that of the critical value. Critical value at 99% level of significance. If we take the critical value at 95%, then it will be 1.95. It will be 1.95. See, if it is significant at a 0.01 level, definitely it will be significant at a 0.05 level as well. This is what is the logic. One question is there, please kindly remember it. If it is significant at a 0.01. Definitely it will be significant at 0.05 as well, because the critical value at 0.01 is 2.58. The critical value at 0.01 is 2.58, whereas the critical value at 0.05 is 1.95. Means the critical value at 0.01 is greater than that of the critical value at 0.05. If the Z value is greater than the critical value at 0.01, definitely it will be greater than the critical value at 0.5. Means while testing the hypothesis, if it is significant at 0.9 level, definitely it will be significant at 99% level of significance as well, 0.05 level as well. But the converse is not true. The converse may true, may not true, based on the result you will get. Now, see, based on this calculation, Z calculated value is greater than that of the Z critical value. So what we can say, the null hypothesis is rejected. We can simply say that the null hypothesis is rejected. If the null hypothesis is rejected, what was the null hypothesis? Null hypothesis states that there is no significant difference between the sample mean and the population mean. Null hypothesis states that there was no significant difference between the sample mean and population mean. But after making the calculation, we reached at a point where null hypothesis is rejected. We are not going to accept the null hypothesis. We are going to reject the null hypothesis. So which one is accepted? We are going to accept the alternate hypothesis. So if null hypothesis is rejected, what interpretation can be made? We can say that there is a significant difference between the sample mean and population mean. There is a significant difference. There is a difference, and the difference is significant. Most important is the difference is significant. There is a significant difference between the sample mean and population mean. So what we can say? The sample mean is not equal to the population mean. Sample mean is not equal to population mean means our alternate hypothesis is retained. So here we can say that the null hypothesis is rejected and alternate hypothesis is accepted. So we are 99% confident that there is significant difference between the sample mean and a population mean. So what is the probability? The probability is p value is equal to 0.99. So only the probability is 0.01 that the sample mean may equal to the population mean. Means see the probability. The probability is 0.01, only 0.01 that the sample mean may equal to the population mean. But the probability is very insignificant. So we can say that there is a difference between the sample mean and population mean. So what was the question? The question was asked, test 0.01 level of significance, that sample mean and population mean who's out 90 and deviation, and the standard deviation is 23. So we are 99% confident that the sample mean is not equal to the population mean. There is a difference between sample mean and population means, and the difference is statistically significant. We have enough evidence. Statistically, we can say that we have enough evidence to reject the null hypothesis and state that there is enough evidence to say that sample mean is not equal to the population mean. Okay, so this is what is the question pertaining to your check your progress 1. If there is any question, feel free to raise your hand or feel free to ask the question. I am with you. Okay. So 15 to 30 seconds, I will wait for you for any question based on this one, any query. Then I will go to check your progress 2. Or should I go?
Sir, just a simple question.
Yes.
How do you calculate the Z 0.01, the critical value at 0.01? Is it calculated?
Critical value 0.01. See, yeah. Critical value 0.01 means 99% level of confidence.
No, you got the, it has 2.58, we got the value, no? 2.3. Yeah. How did you get that value?
From table you will get. If you look into the table A, enter into the table A.
Okay.
Enter into the table A. What we need 99%.
Okay.
0.01 level of significance means 99% level of confidence. So 99% level of confidence. For 99% level of confidence, enter into the table A. If you enter into the table A, you will find that left hand side it is at a 0.0, and the right hand side horizontal column you will get that is 5.8. Where the two lines cross each other, that value is coming 2.58.
Okay.
That is the we obtained from the table critical value.
Okay. So that's
Where
there's only
all
one table.
If you look into all the questions of week 2, if you look into all the questions of week 2, you will find that all the questions are of similar type. To find out the critical value at a 0.01, find out the critical value at 0.05, find out the critical value of 0.10, find out the critical value of 0.15, like that. So simply I have used the table that is given in the resource page.
Okay.
If you enter into the week 1 first table, that is table A, it is already given. Download the table and find the 99% area enclosed in the within the normal probability curve. 99% area will be within the normal probability curve. It corresponds to standard value 2.58. So that is what the critical value. Similarly, 99% if you look into, you will get 1.96.
Okay.
So as in the previous session we were discussing, generally in social science discipline, whatever the research work we do, whatever the statistical calculations we do the calculation at a 2 level of significance. One is 99% confidence level, another is 95% confidence level. So it is more appropriate to have 99% confidence level than that of the 95% confidence level. But what percentage will be taken depend upon the nature of the study, depend upon the sensitivity of the study, depend upon the level of accuracy an investigator intended to have in the study. Always it is preferred that higher level of significance is better, but it depends upon the nature, purpose, and the importance of the study. I hope you got the idea. In case of any doubt, refer to the table A. In case of any issue, please speak to me. Once again, we will have a discussion.
Okay. Thank you, sir. Thank you.
Any other question, please? Or I will go to the next question. Should I go to the next one?
Yes, sir.
Okay. Let me see the question number 2. Please have a look. Already you have seen it in the module, and many of you must have solved it, I am sure. But just see the question. What exactly the question? And based on the question, what is striking to your mind? That is important. Make your own analysis. Make your own analysis. Okay. Number of passengers using airways at a particular airport in last 3 months were recorded. Okay. Last 3 months means 90 days. Were recorded. The mean was found to be 360. Mean of the sample is 360. Standard deviation is 12. Test the hypothesis that the mean of the passenger is more than 350. We need to prepare a hypothesis and then test whether the mean of the sample is greater than 350. Means 340 is the population mean. That is given in the question. We are required to make a comparison between the sample mean and population mean. The population mean is 350. Sample mean is 360. Sample means that is the sample taken in last 90 days, last 3 months. The last 3 months average is increased from 350 to 360. If the 360 has increased from 350 to 360, means on an average there is increase in 10 passengers per day. On an average there is increase in 10 passengers per day. Now what we have to prove? We have to prove whether the increase in the passenger in last 3 months is a significant increase or simple increase. Because when we are doing a research work, when we are doing a purposeful work, we need to prove it statistically. We need to prove it mathematically. Yes, there is an increase in number of passengers per day, but we are intended, our purpose is to prove that whether this difference, that is 10, difference between the sample mean and population mean is coming 10, 350 minus 360, or we can say 360 minus 350, 10. Is this difference a statistically significant difference or not? If statistically significant difference, we have to prove it. If it is not statistically significant, then we have to prove it, and accordingly we will make our conclusion or we will make our interpretation. So this is what is the question. So look at into the question. What is given in the question? N is given because last 90 days it is given. The average is found out based on the passengers of last 90 days. Average is 360. So mean of the sample is 360. So mu is equal to 360. Then standard deviation is 12. Mean of the population, that is generally mu 0, but we have written it in mean of the population is 350. This is the 4 criteria. This is the 4 important indicators based on the questions. Now coming, what is the null hypothesis? Prepare the half the null hypothesis. Null hypothesis is equal to H0. Null hypothesis states that sample mean is equal to population means. Sample mean is equal to population mean. Or in a better way, if I can frame it, I can say it like this. Null hypothesis states that there is no significant difference between the sample mean and the population mean. Null hypothesis states that there is no significant difference between the sample mean and the population mean. Alternate hypothesis states that there is mean of the sample is not equal to the mean of the population. Mean of the sample is not equal to the mean of the population.
So I have a question.
Yes, please.
For alternative hypothesis, can we put mean of population is greater than 350 instead of mean is not equal to 350?
See, look into the question. It depends upon the question that is asked to you. Yes, I was just about to tell you that one. In the bracket, I have written C. Alternate hypothesis is that mean is not equal to 350. Yes, you have rightly posed the question. Can we write that mean is greater than 350? Or can we write that mean is less than 350? Because see, it is not given in the question. It is given in the question that the average number of passengers per day was found to be 360 and 12. Test the hypothesis that mean of the passenger is more than 350. Okay. Mean of the passenger is more than 350. You are rightly said. Here we can say that mean of the passenger not equal to 350 means it is mu is less than 350, mu is greater than 350. Out of these two, we have to take the second one. Mean of the hypothesis that mean of the passenger is more than 350. As it is given in the question, the last line please underline. See, this is test the hypothesis that mean of the passenger is more than 350. It is given mean of the passenger is more than 350. So in that case, we can frame our alternate hypothesis that alternate hypothesis states that the sample mean is greater than the population mean. Sample mean is greater than the population mean. In this case, can you tell me, is it a one-tail test or two-tail test?
It will be a one-tail test. It will be a right one-tail test.
Only one tail
test. It is a one-tail test. Is it a left-tail test or right-tail test?
right tail test.
Rightly, exactly. It is right-tail test. So mu is equal to, we have mu, alternate hypothesis states that mu is greater than 350. This is what is our hypothesis. So we can say that this is a one-tail test and it is a right-tail test because the mu is greater. We are going to prove whether the mu is greater than 350. We are going to prove, we have to test whether the mean of the passenger is more than 350. We are going to test whether the mean of the passenger is greater than 350. So it is a right-tail test. One-tail, right-tail test. So this is what is the nature of the test. Now, coming to this one. According to the question, this is what is I told you. This is the general way of making the hypothesis. But as per the question, see what is given in the question. According to the question, alternate hypothesis states that mu is greater than 350. What is mean? Mu is the sample mean. Sample mean is greater than 350. Means we are going to test it. So what type of test is this? Already you told it is a one tail test. So it is a right tail test. Rightly you have said it is a right tail test. Now let us come to the statistical part. First of all, find out standard error of mean. Same procedure. What we have adopted in first question, we are going to pose the same procedure in the second question. First of all, find out standard error of mean. If you look into it, the standard error of mean is standard deviation by root over of n. It is coming 1.26. Okay. Our standard error of mean is 1.26. Then find out the z value. Z is equal to sample mean minus population mean by standard error of mean. So 360 by 350 by 1.26. We are getting 7.93. The Z value is coming 7.93. Here we can say that Z calculated value is equal to 7.93. This is what we got from our calculation. From the calculation. Now, if alpha is equal to 0.01, what is alpha? Can anyone tell me what is alpha?
Type 1 error.
It is the no, it is significance interval.
Okay, any other answer?
It is the critical value.
It is the critical value. Any other answer, please?
A significance interval.
Significance level. Significance level.
Okay. Any other answer? Please come up.
Significance value.
See, here we have mentioned alpha is equal to 0.01, then we have mentioned alpha is equal to 0.05. Why I have mentioned 0.01 as well as 0.5, I will explain. But tell me, what is alpha? What does alpha represent?
Yes, it is the significance value.
Exactly. Alpha represents the level of significance, the level of confidence. Alpha is equal to level of significance. Level of significance is 0.01, means 99% confidence level. Alpha represents level of significance or confidence level. If alpha is equal to 0.01, means 99% confidence level. At 99% confidence level, the critical value is 2.58.
So I have a question.
Yes, sir.
Since this question did not state a significance level to use, I used two different levels. The smallest significant level that you stated was 0.001, so I used that, as well as.
Yes, you can use it, absolutely.
Since
I told you, see, you can
since the Z value was.
You can increase the level of significance, absolutely, there is no issue. But remember, while increasing the level of significance, we are committing. There is a chance we are not committing. I can say that there is a possibility of committing error. What is that error? That is what is called the. How many
Should be type 2 error.
Type 1 error and type 2 error.
Type 2 error.
Type 2 error.
Increasing the level of significance. While increasing the level of significance, there is a probability of reducing type 1 error. But at the same time, there is a probability of increasing type 2 error. Last time, towards the end, we had a discussion. Always we have to make a balance between the type 1 error and type 2 error.
Yes.
Always we have to make a balance between the type 1 error and type 2 error. How to make a balance? It depends upon the nature of the question. It depends upon the sensitivity of the purpose for which the test is being made. And it depends upon how much risk you are able to take. Accordingly, you have to find out the level of significance. Yes, you can from 0.001. There is no problem. There is no issue. Higher the level of significance, greater is the accuracy.
For a Z value of 7.9, which is almost 8, that is about twice the range of the normal distribution. So I think you could go to the maximum of the normal distribution and still be way below the required limit to get the type 2 error. Would that be true?
Yes, exactly. Yes, exactly. True. But I told you what exactly the question you have taken. What level of sensitivity is required in your question? What is the purpose? Accordingly, you take a decision. If you are intended to enhance your level of significance, you can increase it. There is no issue. At the cost of increasing the type 2 error. Even if at the cost of increasing the type 2 error. But whether you are ready to take a risk in terms of type 1 error or type 2 error, it depends upon you as a researcher, you as an investigator, you as a person who is handling the problem, who is solving the problem. It is no other to take the decision. So as I told you, I will show you an example also towards the end. Last time also we had discussed one example. So this time also we will discuss. But see, that is what is the purpose. Accordingly, you need to take a decision. Anyway, so alpha represent 0.0. I am taking the standard level only 0.01 and 0.05. That is 99% confidence level and 99% confidence level and 95% confidence level. So what is the critical value? 2.58 at 0.01 level. So we can say that calculated value 7.93. Our critical value is 2.58. So calculated value is greater than the critical value. Calculated value is greater than the critical value. Similarly, at 0.05, you will find that the critical value is 1.96. Again, the calculated value is greater than the critical value. So at both level of significance, whether you choose 0.01 level of significance or you choose 0.05 level of significance, in both the case, the calculated value is greater than the critical value. As the calculated value is greater than the critical value, we can at both the level of significance, calculated value, that is Z calculated, lies within the area of a rejection. So we can say that null hypothesis is rejected. This shows that null hypothesis is rejected. If null hypothesis is rejected, but we can say the mean of the passenger is greater than 350. Null hypothesis is rejected means, what was the null hypothesis? Null hypothesis states that mean of the sample is equal to mean of the population. Null hypothesis states that there is no significant difference between the sample mean and population mean, but we don't retain the null hypothesis, rather we are rejecting the null hypothesis. The moment we are rejecting the null hypothesis, we can say that the mean of there is a significant difference between the sample mean and population mean. And we are 99% confident that there is a significant difference between the sample mean and population mean. And this difference goes in favor of sample mean, not in favor of this difference goes in favor of population mean, that is 350, not in favor of a sample mean. As the difference is in favor of the population mean, we can say that the sample mean is not equal to population means. So the last 90 days statistics that was collected, the last 90 days record that is collected doesn't show that mean of the passenger per day has been increased. Even though numerically the value is greater than that of the population mean. Numerically, the value was 360. Numerically, that value was 10 more than the population mean. But statistically, that value under these circumstances doesn't seems to be a significant difference. It is not significant, rather it is null hypothesis is rejected. The difference is in favor of a population sample, not in favor of the sample mean. So we can say that even though there is increase in the numerical numerical indicator shows that there is increase in number of passengers per day, but statistically, research point of view, we can say that the difference is not significant. So there is no increase in number of passengers in last 90 days. So this is what is the point with respect to your check your progress too. Now, any question, or I will go to the next one. Devjanji.
I'm good, sir.
Yes. Do you want to ask anything?
No, sir, I'm good.
Okay. Now, if there is any question, please ask, or else I will go to the reflection question 1, 2, 3, 4. We'll start from 1. I hope many of you have already completed the reflection questions.
Yes, sir.
Yes. Please, if those who have completed, kindly compare your result with the result we have been discussing. And the interpretation you have made with the interpretation we have been discussing now. And those who are in the process, kindly take it the point and move ahead. And those who have not started, please do it immediately so that it would help you in taking up the assignment questions as well. Okay, so the next first question is that this. Look into the question. Okay, this is what is the question. If you analyze this question on the basis of analysis, what information we are gathering, let us put the, I have given n is equal to 50, mean of the sample is 4997, mean of the population is 5000, standard deviation is 6. What we have to do? We have to test at 0.01 level of significance. If the, yes, at 0.01 level of significance, if the machine works properly. This is what is the question. Okay, see. What is your null hypothesis? There is no significant difference between sample mean and population mean. Always we are going to test the null hypothesis in order to reject the null hypothesis. As a researcher, our intention is to reject the null hypothesis, but it depends upon the statistical value we are getting. It may be rejected, it may be retained. If it is rejected, we will make the analysis accordingly. If it is retained, we will make the analysis accordingly. So that is what is the test. That is what is the proof in a research study. Now, can you tell me what type of test is this? It is a one-tailed test or two-tailed test?
It is a two-tailed test.
Two-tailed test.
Why it is a two-tailed test?
Because we have to make sure that it works properly.
If
We can
it
do
is a
that.
two-tailed test, can anyone tell me it is a directional hypothesis or non-directional hypothesis?
It is a non-directional. The alternate.
Alternate hypothesis is said to be non-directional hypothesis. See, alternate hypothesis may be a directional hypothesis, may be a non-directional hypothesis. It depends upon the way you are framing the alternate hypothesis. And the way of framing depends upon the questions that are asked. The way of framing, I cannot frame it by my own. It depends upon the question. So in the question, what it is asked to you? In the question, it is asked to you that test whether it is, sorry, what I got is that, yes, what is asked to you? Test at a 0.01 level of significance if the machine works properly. So it is a non-directional hypothesis. Two-tailed test, non-directional hypothesis. So find out the standard error of mean. Standard error of mean is 0.85. I don't know what value you got. Those who have completed it, kindly check. Process remains the same.
Yes, sir. 0.85.
Okay. 0.85. Then find out the Z value. D by ACM. Modulus of D, mod D by ACM. You will get 3.53. Did you get it?
Yes, sir. I got 3.54.
Very good. Okay. Now coming to the, what is your calculated value? So calculated value is 3.53. Calculated value is 3.53. What is the critical value at 0.01 level? 2.58. So now make a comparison between the calculated value and critical value. You will find that the calculated value is greater than the critical value. Okay. See, the calculated value is greater than the critical value. If the calculated value is greater than the critical value, null hypothesis is rejected. The moment you are rejecting the null hypothesis, remember what was the null hypothesis. This is very important. There was no significant difference between the sample mean and population means. But actually, there is a difference, and the difference is significant between the sample mean and population means. So Z calculated lies in the area of rejection. So there is a significant difference between the sample mean and a population mean. So what we can say? What we can say? So the machine doesn't work properly.
Yes,
This shows that there is some error. The machine doesn't work properly the way it should have been worked. Because we are rejecting the null hypothesis. Had we been retained the null hypothesis, then we could have said that the machine worked properly. So there is no significant difference. So this is all right. But in this case, we find that there is a significant difference between the sample mean and the population mean. Means alternate hypothesis is retained. Alternate hypothesis is written. See that alternate hypothesis is a research hypothesis. Null hypothesis is a statistical hypothesis. Can anyone tell me why null hypothesis is called statistical hypothesis?
Because we
Because
select
it's
or
mentioned the
reject
status quo.
according to statistics.
According to statistics? Yes, ma'am, please tell. Yes, it is correct. Please tell.
Sir, we reject or select the hypothesis according to statistical process.
Okay, fine.
So it's
why
called
it is-
it's called statistic hypothesis. If null hypothesis is rejected, then alternative hypothesis automatically considered.
Any other answer? Yes, actually correct. Any other answer?
The null hypothesis maintains the status quo.
Why
Why
the
the
null hypothesis
alternative?
is called
The proof.
it's called statistical hypothesis? My question is that why the null hypothesis is called statistical hypothesis? See, null hypothesis is called statistical hypothesis because out of the two hypotheses, which one is subjected to test? Null hypothesis is subjected to test, or the alternate hypothesis is subjected to test. Always the null hypothesis is subjected to test. Means we are testing the null hypothesis. Based on the result of the test of null hypothesis, we are going to retain the alternate hypothesis, or we speak something about the alternate hypothesis. Never we examine or never we test the alternate hypothesis. Always the null hypothesis is subjected to test. So the statistical calculation what we do, based on the calculation, we are going to make a remark on the null hypothesis. Means null hypothesis is always subjected to test. As null hypothesis is always subjected to test based on the statistical data. Based on the statistical data. So null hypothesis is otherwise always called a statistical hypothesis. And based on the result of null hypothesis, we are taking a decision, we are taking a statement whether to retain or whether to reject the alternate hypothesis. So that is why alternate hypothesis is the research hypothesis. Now coming to the next one. This is the question number 2. See, we'll quickly run into it. There are many questions I am getting from the forum. What is the use and applications of these statistical inference or statistical calculations? What we are doing, or the testing hypothesis? What is its use? What is its application? Why we do it like this? So look into the questions we are handling. We are handling different varieties of the question. So these are the questions from different background. These are the questions from different disciplines. These are the questions from different areas. Those who are working in those areas or those who will work in those areas, it is of use for them to take a decision. So accordingly, if I am working in my area of discipline is as a academic, I am working in the field of higher education, I need to prepare my questions in the similar way so that I can make use of this research. I can make use of these calculations. I can make use of the statistics for the improving the learner's proficiency or enhancing the learner's level of achievement. Anyway, now coming to the question number 2. In COVID-19, this is what is very important for the all field workers, those who are working in the field. In city COVID hospital, the average heartbeat per person in the age of 40 to 50 is 72 minutes with standard deviation 12 beats per minute. Group of 50 patients are examined and the average heartbeat was found to be 75 beats. Test whether the difference is significant at 0.1 level of significance. Is it a one-tail test or two-tail test?
It is a two-tail test.
It is a two-tail test because no direction is given. We are going to test, but there is no direction in testing, in making the test. Whether we are going to test it greater than sample mean or we are going to make it a smaller than sample mean. As no direction is given, it is non-directional and a two-tail test. So what informations are given in the question? if you look into it, these are the 4 information given. The moment you find a question, first of all, immediately see what is the given information. These are the given information. Taking the given information, what can be determined? That is most important. Now, if you want to determine that, what is the formula? So, population mean is given, sample mean is given, standard deviation is given, sample size is also given n. So, what we have to do? We have to test whether the difference is significant at 0.1 or not. See, what is the sample mean? The sample mean is 35 bits. The average heartbeat is 75. What is the population average? The population mean is 72. Is there any difference between the sample mean and population mean? Answer is yes, there is a difference. How much difference? The difference is 3. 75 minus 72. The difference is 3. Now, in the question it is asked to you, test whether the difference of 3 is significant at 0.01 level or not. Means alpha is equal to 0.01. In the question, the level of significance is given. If the level of significance is not given, you may take at 0.01 or you may take at 0.05 or you may take at both the level. But very clearly, alpha value is also given in the question, that is 0.01. We have to make an analysis, we have to make an interpretation at a 0.01 level of significance, means 99% confident level, we are going to make the analysis. Okay. The analysis is to be made, the interpretation is to be made at 99% confidence level. Or we can say probability is equal to 0.01. The sample mean is not equal to population. See, what is the standard error of mean? This is what is the standard error of mean. Based on the question, the standard error of mean is 1.69. What we have to find out? We have to find out the Z value. This is what is the Z value, 1.77. Is it fine? So we can say that calculated value is equal to 1.77. Our calculated Z value is 1.77. What is the alpha value? 0.01. Alpha is equal to 0.01. At 0.01, what is the level of significance? 99% level of significance. What is the critical value? 2.58. Again, this is I got it from the table. Critical value 2.58. Now we have to make a comparison. We have to make a comparison between the Z calculated value and the Z critical value. Is it okay? If this is the case, what we can say? 1.77 is smaller than 2.58. Or I can say it like this. The Z calculated value is smaller than the Z critical value. The calculated value is smaller than the critical value. So what analysis can be made? Sorry, what interpretation can be made? The difference between the sample mean and population mean is not significant. What was the difference? Difference was 3. 75 minus 72. The difference was 3. What is the null hypothesis? Null hypothesis states that sample mean is equal to population mean. Null hypothesis states that sample mean is equal to population mean, or we can say that there is no significant difference between the sample mean and population mean in terms of a statement. In a research study, if you are putting it in the form of a statement, you can put it like this: there is no significant difference between the sample mean and population mean. So the difference between the sample mean and population mean we are going to test. So here we find that the calculated value is smaller than the critical value. The difference between the sample mean and population mean is not significant, means null hypothesis is not rejected. We don't reject the null hypothesis, rather in this case null hypothesis is retained. We can say that null hypothesis is true. In this question, as per the calculation we got sorry, as per the statistical calculation we made, we can say that the null hypothesis is not rejected, null hypothesis is retained. The difference between the sample mean and population means 3. The difference numerically there is a difference of 3, but this difference is not significant. This difference is not significant. So what is the level of confidence? We are 99% confident in saying that the difference between the sample mean and population mean is not significant. By saying this statement, how much error we are committing? We are making only 0.01%. We are making only 1% error. We are making only 1% error. We make wrong in 1%. That there is no significant difference between the sample mean and population mean. But we are 99% confident that there is no significant difference between the sample mean and population means. So the probability of the chance of error is 0.01. The probability of chance of error is 0.01, but the probability of the level of confidence, that is 0.99. 0.99. So this is what is the interpretation you have to make. The probability of chance of error in this case is very, very less. That probability is said to be 0.01. So we make 1% wrong in giving this statement that the sample mean is equal to population mean. But as per our calculation, there is no significant difference between the sample mean and population mean. So the difference, we are 99% confidence in stating that. This is what is the question. Okay. Now, let us come to question number 3. Any question from your side? If there is any question, please ask. Please record the answers. Note the answers. Today, the answers will not be given in the resource space. Week 3 and week 4's answers will not be given in the resource space. Those who are missing it, if they require, they may go through the YouTube video. Or if you have doubt, you may use it again and again. So now I am open with you. I am with you till the end of the whole time. Any question, any query, I am ready to take. Okay. Now coming to this is what the hypothesis. Okay. Now coming to the question number 3. This is our question number 3. Please look into the question. Please look into the question. Questions are very simple. Only we need to understand the question. We need to make a thorough analysis of the question. Question means it is a problem. Taking this one, you can make a title. One question means one problem. Taking the problem, you can make a title of the study. Based on the title of the study, you can prepare an introduction, you can prepare the objective, you can prepare the issues, you can prepare the context, you can prepare the objectives, you can prepare the hypothesis. Exactly. So my point of saying is that try to relate it to your assignment. Exactly in the same way, you have to prepare a question of your own for the assignment. Now, see, this is about a shoe company. A shoe company manufactures shoe having average life 365 days with standard deviation 50. With new technology, the company manufactures new shoes. Random sample of 50 shoes found to have an average life of 380 days. Can you say with 99% confidence that the new technology gives better result in production of the new shoe? Okay, see. This is the average life of a 50 shoes, 380. Means sample mean is 380 days. Sample mean is 380 days. How many samples are there tested? 50 samples are tested. What was the population mean? 365. The population mean was 365 days. So if you compare the population mean with the sample mean, you can say that yes, there is increase in average life of the shoe. There is increase in average life of the shoe about 15 days. About 15 days. Now we have to test whether the increase in average life of the shoe, that is 15 days, is it a significant difference or not? Is there a difference? Because with use of technology, the average life is increased from 365 to 380 days. with use of technology, the average life of the shoe is increased from 355 to 380 days. Now let us test whether the increase in average life of the shoe because of with the use of new technology is significant or not. If it is significant, well and good, the technology works properly in preparing the new shoe. If it is not significant, the technology doesn't work in terms of increasing average life of the shoe. That is what we are intended to do in this question. But simply saying, yes, 365 minus 380, we are 15 days more, so it is better, the technology is better, and it is producing better shoes. We cannot say it like that. Because there should be scientific way, there is a systematic process, there is a statistical way of representing and making a analysis at a certain level of confidence. Now see, what is the next one? What we have to do? We have to test, is there a significant difference between the sample mean or not? At what level of significance we are going to test? 0.01 means alpha is equal to 0.01. Is it fine? That is whether the new shoe gives better result or not. New shoe gives better result means whether the technology used in preparing the new shoe gives better result or not. So in order to test that one, we have to find out the level of significance, and the statistical process is to be applied. Now what is the statistical process? See. Okay, first find out the Z value. Find out the Z value. Okay, see, our Z value is 2.02, 2.12. Means calculated value is 2.12. If the calculated value is 2.12, so we can, and the critical value at 0.01 is 2.58, we can say that the calculated value is less than the critical value. The calculated value 2.12 is less than the critical value. If the calculated value is less than the critical value, what we can say? Null hypothesis is rejected. What was the null hypothesis? There was no significant difference. Null hypothesis is rejected. There is null hypothesis is, there is significant difference between the sample mean and population mean. So this difference, hello, this difference is in favor of the sample mean. So what we can say with this? With this, what conclusion can be drawn? This shows that new technology produces better result. So, as there is a significant difference between the sample mean and population mean, we can say that this significance difference is because of the emergence of the new technology or application of the new technology. With the application of the new technology, the new shoe that is produced and the 50 samples that are checked was found to have an average life of 15 days more than that of the average life of the population mean. So which gives better result.
So could you go back to the 80, to the hypothesis statements, please?
Can you please repeat it?
Can you go back to the hypothesis statement, please, 80 and HA for this question?
I did not get it.
The 80 and HA for this question.
0.01.
No, the hypothesis is it that the mean of the population is equal to 365 and mean of the population is greater than 365. I wanted to see what you had.
No, we have to set the null hypothesis. Null hypothesis states that mean of the population is not equal. There is no significant difference between the sample mean and population mean. Null hypothesis, we have to see that there is no significant difference between the sample mean and population mean. Alternate hypothesis states that there is a difference between these two. Is not equal to mean of the sample is not equal to population.
We are testing that the technology would give better results. So shouldn't we test that the alternative hypothesis would be mean of population is greater than 365 instead of
So,
not.
we can accept the alternate hypothesis based on the result of the null hypothesis. Because always in all the statistical procedure, we are going to test the null hypothesis.
Right. And the other thing is we have here the calculated value is less than the critical value. So H0 should be accepted, not rejected.
Yes,
Yes,
null
that is
hypothesis
Yes,
should
yes.
be selected, not rejected.
Yes, that is true. Yes, what is our yes? This is a point. Calculated value is 2.12. Calculated value is less than the 2.58. That is less than the critical value. Okay.
For this, I also used a right tail test because my alternative hypothesis was the mean of the population was greater than 365.
Okay.
I also got it to be accept 80.
Yes, fine. Then yes, I agree. Fine.
Here, null hypothesis is to be accepted.
Yes, null hypothesis is accepted. Yes. Yes, as it is less than 2.58, 2.12 is less than 2.58. This one should be corrected. It is not rejected, it is accepted. It is accepted. There is significant difference. There is no significant difference between the sample mean and population mean. Okay. Yes, that is true. Fine.
Okay, sir. Thank you. Thank you.
Now, coming to the next one. Yes, agreed. Absolutely fine. Now, coming to the question number 4. See, question number 4 is very interesting one. Please look into it. If you find that the mental ability of a set of a test sample of 150 tribal youth, 20 years age, drawn from a population, the mean and standard deviation was found to be 105 and 12 respectively. If a sample of 30 were drawn from a population, 30 were drawn from a population, 5 different bits are given. Look at the 5 bits. All the 5 bits are very interesting. Okay, all the 5 bits are very interesting. Now, see, one by one, we will check the bits. Coming to the question. Mean of the population is sample size is 150. Because see, mental ability of a sample of 150 tribal youth is taken. So n is equal to 150. What is the mean of the sample? What was the mean? See, that is also given. The mean of the standard deviation was found to be 105 and 12. So coming to this one, mean is equal to 105, standard deviation is 12, n is 30. N is 30. So what is our first bit? What is the first bit? What is the probability that the sample mean will be 100 or less? What is the probability that the sample mean will be 100 or less? Before going to find the probability, just first find out standard error of mean. As we know, sigma by n, we are getting standard error 2.19. I hope this is clear. Our standard error is 2.19. Okay? Come. What is the probability that the sample mean will be 100 or less? In the question, the mean that was given, that is the population mean. Make note of it. In the question, the mean that is given, that is the population mean, MPOP. Now, in the first bit, what is the probability that the sample mean will be 100 or less? Sample mean will be 100 or less means MS is equal to 100. Now, 100 minus 105 by standard error of mean 2.19 we got. So, how much is the Z value we are getting? Z value 2.28. See, our Z value is 2.28 we got. Please note your answer and record it. We find that below 2.28, what percentage of cases are there? Below 2.28, what percentage of cases are there?
So
This
the
we have
answer,
to get it from the table. Okay, there is a table D that is given. There is a table that is given. This is what is the table value. Below 2.28, what is the percentage of the cases? The percentage of the cases below 2.28 is 0.0113, means 1.13% of cases. Okay. Hence, what is the probability of the mean getting a mean 100 or less? The probability of getting a mean 100 or less is 0.0113. The probability of getting a mean 100 or less is 0.0113. Means very low probability, only the probability is 0.0113. What was the question? Look at the question. It was given, what is the probability that the sample mean will be 100 or less? Sample mean will be 100 or less. So find out the Z value. Based on the Z value entered into the table, from the table we get the probability value. 2.28. If you enter the table, we will get 0.0113% of cases, or 1.13% of cases, or the probability is 0.0113. So the answer is, the probability of getting a mean 100 or less is 0.0113. How much you got, I do not know. Kindly check the answer and record it. Okay. Next question. What is the probability that the sample mean will be 105 or more? What is the probability that the sample mean is 105 or more? Exactly, process is same. Sample mean minus population mean by standard error of mean. Here interesting, sample mean is 105 or more. Population mean is also 105. 105 minus 105, which is becoming 0 by 2.19. 0 by something is always 0. 0 by something is always 0. So we find that above 0Z, standard value is how much? Above 0Z, there are how many cases? 0.5 cases. 0.5 cases. Hence, the probability of getting a sample mean 105 or more is 0.5. So here in the second bit, the probability is 0.5. Okay. Now coming to the next one. What is the probability of having a mean that would differ the population mean by 5 points? Means the sample mean minus population mean is equal to 5. Difference is given directly. So the difference is, if the difference is given, the difference may be greater than 5, the difference may be less than 5. It is not given. So anyway, Z is equal to D by ACD, which is equal to 5 by 2.1819, which is 2.28. Again, as it is given, what is given? What is the probability that having a mean would differ from population mean by 5 points? We have to find out the area outside plus minus 2.28. The area outside plus minus 2.28 means we have to subtract minus 2.28 to plus 2.28. So 2.28, what is the area enclosed? That is 0.113. Already in the first bit we got it. So again, plus 2.8, that is also the value remains the same. Add both the value, you will get 0.226. You will get 0.226. Now, what is asked to you? What is asked in the question? The probability of having a mean that would differ the population mean by 5 points. Hence, the probability of having a mean that would differ the population mean by 5 points is 0.0226. This is the probability. Means both sides we have to add. That is the reason here we have mentioned the difference may be on either direction, maybe in positive direction, maybe in the negative direction. The difference may be in either direction. If the difference is in both the direction, so you may add the area beyond the minus 2.28 and the area beyond plus 2.28, which is coming 0.266. Right. Now the fourth bit is find the deviation of the sample mean from the population mean at probability 0.01. Find the deviation of the sample mean from the population mean at a probability 0.01. Means at 0.01, what is the critical value? 2.58. So optimum deviation is asked to you. Find the deviation of the sample mean from the population means. Optimum deviation at 0.01 level is 2.58 ACM. Had it been 0.05 level, this value, the critical value would have been 1.96. But as per the question, we are taking 0.01, that is 99% confidence level, critical value is 2.58. So maximum deviation, optimum deviation will be 2.58 ACM. That is 2.58 into 1.96, which will be 5.56. So this is the answer. So what is the question asked to you? Therefore, probability less than 0.01, the deviation of the sample from the population mean will be 5.56 or less. At 0.01 level, the deviation will not be more than 5.56. The optimum deviation is 5.56 or even it is less than that. Similarly, you can find out if the optimum deviation or the deviation of the sample mean from the population mean will be asked at a 0.05 level. Depending upon the question, you have to make an analysis. Okay. Now coming to question 5.
So could you go back to the last slide, please?
Yes.
On this slide, right?
Yeah.
Right. On this slide where you have P is less than 0.1 and you have Z 0.1 equal 2.58. Right? Right. That should be for a confidence interval. However, this is not between the levels. This is less than. So I had put Z equal negative 2.33, because at that level it will be less than 0.1. Z is equal to negative 2.33.
How did you get it?
I looked for 0.1 on the table and took the Z value.
0.01, not 0.1, that is 0.01.
0.01, yes. So if you look at negative 2.33, negative 2.33, you will get 0.099, which is the probability of 0.1, right? That is your Z value for less than.
See, the simple calculation is 0.01 corresponds to 99% confidence level.
Yeah.
0.01 corresponds to 99% confidence level.
But
at 99% confidence level, the critical value is 2.58. 2.58. So what would be the optimum deviation? Plus minus 2.58 ACM. The optimum deviation will be plus minus 2.58 ACM. Standard error of mean.
So when you say probability is less than 0.1, you mean a confidence level of 0.1?
Yeah.
Okay.
Confidence level of 0.1. So optimum deviation I am going to find out. So the optimum deviation will not be more than 5.6. It may be 5.50, it may be 5 point, it may be 4, it may be 3, it may be 2, it may be 1, it may be 0, but the maximum deviation will be 5.56. This is what is the question asked. Find the deviation of sample mean from the population mean at 0.01. Probability is less than or equal to 0.01. So the moment we are finding out the optimum deviation that is a range. That is a range. That is plus minus 2.58 ACM. Less than or equal to 2 given. So I will not go to the higher side. I will come to the lower side. So 2.58 ACM, 5.56. So whatever it will be the result, it will not be more than 2.58. Always the deviation will be 5.56 or less. This is what is intended to tell. Got it?
Yes, sir.
Okay. Now coming to the question number 5. See the question number 5. If you look into the question number 5, under a special intervention randomly selected, 40 students of standard 10 taken an exposure visit to different science park in the month. A test was conducted to measure the scientific temper of the sample, and at the end of the intervention, the mean of the was found to be 66, standard deviation 12. If the population mean is 61, can we say at 90% confidence level that the special intervention gives better result in improving the scientific temper of the sample?
So you are frozen.
I think Dr. Das has lost his connection, and I request all of you kindly have patience. He will join back soon. 1 or 2 minutes probably. Please have patience. Thank you very much for your cooperation. He's joining back soon. I request all the participants kindly, if you have any query, you just post your query on this chat box. And just I get confirmation he's joining back soon.
Hello, am I audible now?
Yes, Dr. Das.
Yeah. I'm sorry
Yes, we
because
can
of the
hear you now.
sorry because of some technical problem it was disconnected.
Yes, we can hear you.
So I'm just sharing. So we have completed up to question number 4. Let me start the question number 5. So hurriedly we'll finish now. Dr. Manas, kindly allow me to share the screen, please.
Yes, you are allowed. Please.
See the question number 5. If you look into it, you will get that a special intervention was made. In that intervention, standard 10 students were taken, 40 students were identified. We are at question number 5. Okay. This is the question. Did you get the screen, please?
Absolutely.
Yeah. See, the 40 students were identified. Those 40 students are given an opportunity for a exposure visit to different science park. After that, a test was conducted to measure their scientific temper based on the intervention that was given. The mean was found to be 66 and standard deviation was 12. So after the intervention, the mean was 66, standard deviation was 12. If the population mean is 61, population mean is 61. Now the question is, can we say with 99% confidence that the special intervention gives better result in improving the scientific temper of the selected sample? Means we are going to test whether the intervention gives a fruitful result or not. So though there is increase in the mean of the sample, that is population mean was 61, whereas sample mean is 66. So there is an increase of 5. We wanted to test whether the 5 is a significant difference or not. Whether it is significant or not. If significant, is it in favor of the sample mean or not? So that is the point. So this is an experimental study, and the question is framed from that experimental study. If you look into it, this is what is the given data. Sample mean is 66, population mean is 61, number of the samples selected was 40, standard deviation was 12. So what would be our null hypothesis? Let us frame the null hypothesis. Null hypothesis states that there is no significant difference between the sample mean and population mean. If there is no significant difference between sample mean and population mean, means null hypothesis, sample mean is equal to population mean. Okay, so what is the alternate hypothesis? So alternate hypothesis states that sample mean is not equal to population mean. So sample mean is not equal to population mean. Here it is a one-tailed test. It is a two-tailed test, because it is not given that sample mean is greater than population mean or sample mean is less than population mean. It is a non-directional hypothesis. Alternate hypothesis, this set is a non-directional hypothesis where we can say that the alternate hypothesis said that sample mean is not equal to population means. It is non-directional, so we can say that it is a two-tailed test. It is not a one-tailed test, it is a two-tailed test. Simply find out the standard error of mean. As usual process, we are getting 1.89. Then find out the Z value, Z calculated value, that is sample mean minus population mean by SEM. Answer is 2.64. Now make your own. Everything is very clear. Now there is no difficulties of any kind. What is the calculated value? 2.64. Fine. What is the critical value at 0.01 level? 2.58. Means we are making the comparison alpha is equal to 0.01. 99% confidence level, alpha is 0.01. Is it clear? Then critical value, our calculated value is less. Sorry, it is not less than, it is greater than the, because 2.64. Or it is 2.64. 2.64 is greater than 2.58. 2.64, it is not less than, kindly make a correction, please. This is greater than. So calculated value is greater than the critical value. If calculated value is greater than critical value, null hypothesis is rejected. There is a, so what we can say, simply saying rejection would not fulfill our purpose. We can make a qualitative analysis, we can make a qualitative interpretation that there is a significant difference between the sample mean and population mean. And thus, there is a difference, the difference is significant, and the difference goes in favor of sample mean. The difference goes in favor of sample means that we are 99% confident that the special intervention yields a better result in improving scientific temper of the students.
So I have a question.
Yes.
Since the values are so very close, like if you subtract 2.64 from 2.58, you'll get 0.05.
Yes.
Right? Within the possibility of errors, like a type 1 and type 2 errors, shouldn't we say that they are equal and that this is not significant enough to reject 8.0?
Now, see, statistics is statistics. Calculation is calculation. Even if it is 0.1 greater, then it is, yes, it is greater. Now, you can say that as a teacher or as a researcher, as an investigator, you can say that it would have much better. It could have been much better. You can say it like that. But as for the mathematical interpretation is concerned, based on the mathematical interpretation, 2.58 to 2.64, even if the difference is a small one, we can say that the calculated value is greater than the critical value, so it is rejected, and the intervention gives a positive result. And yes, in order to make it more positive, we may put more efforts, we may put more intensive care, intensive measure to make it much better. That is fine. As the difference is very small. If as a teacher or as an investigator, as a person who is conducting the study, if you wanted to improve it more, yes, this is a lesson on the part directly or indirectly. This could have been much better if the interventional part will be, if the intervention will be made more intensive. So as a organizer, as a team member, we should take more care to make the result much better in subsequent interventions. But so far as this particular intervention and this particular calculation is concerned, we can say that yes, it is the intervention seems to give a better result in enhancing, in improving, in increasing the scientific temper of the students.
Sir, you can go back to the next slide, previous slide.
Excuse me.
Previous one. Okay.
Previous
This
one.
one.
Yes, here you say that there is no significant difference between sample mean and population mean.
That is a null hypothesis.
Population mean is equal. Yes, population mean is
hypothesis.
Yes, null hypothesis. So population mean is equal to 61 and sample mean 66.
See,
so,
at this point, I did not calculate. I have not calculated.
Okay, this is assumed. This is assumed that population
before the calculation is made.
Okay. That means we assume that population for null hypothesis sample mean is equal to population mean.
Exactly. There is no significant difference between sample mean and population means. Sample mean is equal to population mean. No difference means what is equal. So it is a hypothesis that is framed before the calculation made.
Okay.
After the calculation, we are going to test whether your hypothesis is correct. You want to retain it or you want to reject it.
Okay. Thank you.
So this is a mathematical form of representation of the null hypothesis.
Excuse me.
Where? This is a mathematical form. Yes, ma'am, please.
The calculated mean is at 2.64.
Yes.
And the Z0 1
Yeah.
is at 2.58. How is
Yes.
it less than? I thought it's
No,
supposed
ma'am. I already told you this is a wrong typing. This is typing error. It should be greater than.
Greater than. Thank you very much.
Yes. This is already I told. I repeatedly I said there is a typing error. It should be greater than. The symbol should be greater than.
Thank you,
Kindly
sir.
note. I request all my learners kindly note and record that this is a greater than symbol. It is misprinted here.
Thank you very much.
Yes, I am extremely sorry for that.
Me for some time now.
No, it is. I am extremely sorry for the typing error. This is a wrong in typing error made. It should be greater than 2.64 is greater than 2.58. Kindly change it. Kindly correct it. And sorry for the typing error. So null hypothesis is rejected. So difference is giving meaningful. The intervention is giving meaningful result in terms of improving scientific temper of the learners. Okay. Now coming to the next question. Question number 6. The question number 6. The average IQ standard deviation of the employees are given. 100 employees are taken randomly. The IQ is found to be 115. Test the significance between the sample mean and population mean. Exactly the same. What we have done, it is exactly the same. See, this is the basic thing that is given in the question. I hope there is no problem in it. Okay. I hope there is no problem in it. Then the null hypothesis. Based on the null hypothesis, then the alternate hypothesis. Then find out standard error of mean. Yes.
So could you go back to the question for a second, please?
Is it?
The question, sir.
Question. Okay.
Question.
This, the question.
Question.
Yes, this is the question.
Go back to the question, sir. The slide.
Do you want the question or I'll move forward? Okay. Question is already there in the reflection question. In the module, you will get it.
Yes, sir.
The slide for the question, sir. I didn't get.
Okay. Now, see, this is the solution.
Yeah.
Population mean is given, sample mean is given, standard deviation is given, n is given. So now frame the null hypothesis, then frame the alternate hypothesis. Okay, you frame the null hypothesis, then you can frame the alternate hypothesis. Then find out standard error of mean. Standard error of mean, sigma by root over of n. We are getting 1.2. Then find out z value, 4.166. In the question, it is very clearly given at 0.05 level of significance. Critical value is 1.96. So the calculated value is much more than the critical value. And if you look into it, you will find that the calculated value is much more than the critical value. 4.166 is greater than 1.96. What we can say? Null hypothesis is rejected. If null hypothesis is rejected, this is the interpretation. See the interpretation. Difference between sample mean and population means is significant. Null hypothesis, there is no significant difference. But here we obtained, here we proved that there is significant difference. What is the level of confidence? 95% level of confidence. That the difference between the sample mean and population mean is significant. Now, coming to the 0.01 level, that is 99% confidence level. This is also significant at 99% confidence level. So the difference between sample mean and population mean is also significant at 99% level. We can say that there is a significant difference between the sample mean and population mean, and the sample mean and population mean is significant at 0.01 level as well as 0.05 level. Okay. Coming to question number 7. Coming to question number 7. Average daily profit of a businessman was 1,000 in last few years. Recently, due to COVID situation, the average daily profit of last how many days? 15 days. Last 15 days was found to be 450 rupees. Standard deviation 46.8. Test whether the daily average of the profit has decreased. Test whether the daily average has decreased. Can you tell me it is a one-tail test or two-tail test?
One-tail test.
One-tail test. Right-tailed or left-tailed?
Left-tail.
Left-tail.
Left-tail test. Exactly. It is a one-tail test, left-tail test. We want to test whether the daily profit has decreased or not. Now, coming to the question. First of all, find out standard error of mean. Your standard error of mean is coming 12.09. Okay. Standard error of mean is 12.09. What is the null hypothesis? There is no significant difference between sample mean and population means the daily profit has neither increased or decreased. What would be the alternate hypothesis? Sample mean is not equal to 1000. Okay, same process.
The alternative hypothesis should be population mean is less than.
Yes, exactly. I am coming. See, so alternate equal to what it is given, it is decreased or not. So we can say alternate hypothesis states that mu is less than 1000. Alternate hypothesis states that mu is less than 1000. Now, find out the t. Can you tell me why we determined the t here? Can anyone tell me? Why did you go for t value instead of z value?
Because it is n equal to 15.
Because we have determined for 15 days only. So n is less than 30. N is less than 30. If the value is less, if the sample size is less than 30, it refers to small sample size. So for small sample size, t test is determined. So t value is equal to d by ACN, which is equal to 45.49. 45.49. We are going to test whether the daily average daily profit has decreased. Whether the daily profit has decreased. Here I have put the question. Is it a what type of test? Already we have discussed it. It is a one-tail test or two-tail test. Yes, it is a one-tail test. Of course, it is one-tail test. Is it left-tail test or right-tail test? Yes, it is left-tail test. Already you have given me the answer. Okay. Now coming to the degree of freedom. What is the degree of freedom? N minus 1. Our n is how much? 15. So 15 minus 1, which is equal to 14. Degree of freedom. Now taking this degree of freedom, 14, the t value to be significant at 0.1 level in one-tail test, you have to find out. If you look into the table D that is given, one table is already given, table D. I hope you have gone through the table. I hope many of you have already gone through the table. Okay, so the table is given. This is what is the table. Yes, this is the table we have given in the resource space. Okay, see the degree of freedom is 14. Degree of freedom is 14, and we are getting the t value from that. Your we are going to read at a 0.02. So where you will get the critical value, because critical value is 2.62. Okay, referring to the table D, you will get the critical value under a degree of freedom 14 at a one-tail test. See, 0.01 level, one-tail test. One-tail test means 50% will be left to the mean, 50% will be right to the mean. It is decreased written, so it will be left to the mean. If it is left to the mean, it is coming 2.62. This 2.62 is coming from the table. 2.62 is coming from the table. Got it? This is what is the value. Just I have underlined it. See, I have underlined it. It may not be visible to you. You see your own table, you will get it. It is coming 2.62. So we can interpret that the average daily profit has decreased or increased. Yes, there is a decrease in the average daily profit. Null hypothesis is rejected because our calculated value is much more greater than that of the table value. The calculated value 45.49, whereas table value with degree of freedom 49, we are getting 2.62. It is much more greater, so it is average daily profit has decreased. Now coming to the question number 8.
Excuse me, sir.
Yes,
please, let's go to I didn't get that number 7 very clearly. Where we
Yeah.
started at t-test
Yeah.
equals to minus sample mean minus population mean divided
Yes.
by standard mean, error of mean. Go to the next, back to the next.
This one.
Here, please. I need further explanation here, sir.
Yes, tell me what it is. Sample mean minus population mean by standard error of mean. Is it clear?
Yeah.
450 minus 1000 by 12.09. Standard error
Yeah.
of mean is 12.09.
Okay.
Okay. The difference is coming 559.
Okay.
559 by 12.09.
Okay.
Okay. Then our this, if you divide this one, our answer is 45.49.
Yes.
45.49 is the calculated value, calculated t value.
Calculated. Okay.
Calculated t value. Always we are trying through the calculation what we are getting, we are saying it calculated t value. So calculated t value is 45.49. Now we have to find out the critical value. For critical value, we need a degree of freedom. Okay?
Yes, sir.
For critical value, we need a degree of freedom. How to find out degree of freedom? N minus 1. 15 minus 1, which is equal to 14. Okay?
So I also have a question for number 7. Could you go to the question itself?
Yes, please tell. Please ask.
Go to the question for number 7 itself. The slide with the question.
Okay. Yes, this is the question.
Right. So I understand what you did for the statistical calculation. I did something similar. However, for a question like this where you can clearly see that the amount is about half, and even with the standard deviation, if you add and subtract, it will be way outside the range of what was given before. Do we really need to go through all this calculation to say, well, it is less? Because even if we add 46.8 to 450, you will get a maximum of 496.8, which is half of 1,000. So visually, I could see that it is clearly less. So is statistical calculation necessary?
Yes, exactly, you are true. If you will be able to make the analysis at this point, taking into that point of view, it is not required. You can make the analysis directly. But from the layman point of view, those who are in the process of learning it, it is always better to follow the process to find the ACM, then find the t value, then go to the degree of freedom, then make the table value, make a comparison, and come to the answer. From your point of view, you are absolutely correct. I agree with you. But this required a thorough understanding, those who have already understood the concept. But for the beginner or for those who are in the not confident enough, they have to follow the process and get the result. But you are correct in saying that. Absolutely. Okay. Now 45.5, then you compare it, the table value is we are getting 2.62. The table value
So why did you go find the value under 0.02?
Okay.
Why did we use 0.2?
See, 0.2.
0.02, sorry, 0.02.
0.02, because we are supposed to go to 0.01, but 0.01 is distributed into two parts. It is given, it is a one-tailed test. It is a one-tailed test. It is not a two-tailed test. Had it been a two-tailed test, we would have taken 0.02. We would have taken 0.02. It is a two-tailed test. So 0.02 is divided by 2, which is equal to 0.01. 0.01 means 50% is left to the normal probability curve. Sorry, 50% is left to the mean, 50% is right to the mean. Okay, sir. Okay, sir. So 50% is coming 0.01. So I have taken degree of freedom under 0.01, which is coming 2.62. Okay, sir. Had it been a two-tailed test, you should not have done this calculation. You could have gone directly 0.02. Okay, sir. Okay. So that is the reason we are getting 2.62. Then make the analysis. Null hypothesis is rejected. We can interpret the average daily profit has been decreased. Now coming to question number 8. I am running short of time. Kindly finish it. So A random sample of 500 gas cylinders has a mean weight of 14.8, standard deviation 0.6, test at 0.05 level of significance that average weight of cylinder is less than 15 kg. Means exactly same ways. Mean of the sample is given, mean of the population is given, standard deviation is given, n is given 500 sample. N is given 500 sample. But we are going to test whether the average weight of the cylinder is less than 15 kg. Less than 15 kg. It is a one-tailed test. It is a one-tailed test and left-tailed test. Remember, it is a one, as per the question, it is a one-tailed test and left-tailed test. Now, again, find out set the null hypothesis, set the alternate hypothesis. Standard error of mean is we are getting 0.03. 0.03. Okay, Z value we are getting 6.67. 6.67. So at 0.05 level, what is the critical value? 1.96. 1.96. As it is a one-tailed test, that is why we have retained the sign minus 6.67 and minus 1.16. So minus 1.167 is smaller than minus 1.19, minus 1.96. Okay, means calculated value is smaller than the critical value. If calculated value is smaller than the critical value, null hypothesis is not rejected. Null hypothesis is not rejected, means null hypothesis is accepted. We are 95% confident that average weight of gas cylinder is 15 kg. Okay, this proves that the average weight of the gas cylinder is 15 kg. Because we are not rejected the null hypothesis, we are accepting the null hypothesis based on the calculation we are getting. The calculated value is smaller than critical value. Okay. Now I am touching upon the last question. See, this is the last question. In a city municipality area, Dr. Manas, kindly give me 5 minutes, please. Maybe 2-3 minutes, I'll finish it. In a city municipality area.
Please go ahead.
Yeah, thank you. In a city municipality area, that is the last question. If you look, yes, party area set to produce 100 kg of waste material for 1 quintal with a standard deviation of 12 kg. Average quantity of random sample of 50 lots of 1 quintal each found to be 110 kg. Test whether the quantity of waste has increased at 0.01 level of significance. See the question. Seems to be little bit confusing and critical, but it is not like that. Break the question into different parts. This is what is the sign of a very good researcher or a very good investigator. The problem, whatever the problem is there in front of you, what is the question is there in front of you, always break it into different parts. If you break it into different parts, what you are going to get, see, we will make it like this. The population is 100. In a city municipality area, set to produce 100 kg waste material per quintal. 100 kg waste material means your population mean is 100. With standard deviation 12 means SD is equal to 12. From the first sentence itself, you will get two values. What is the population mean? From the first sentence itself, you will get what is the population mean and the standard deviation. The population mean is 100, standard deviation is 12. Now, second statement, average quantity of a sample of 50 lots means n is equal to 50. Average quantity of a random sample of 50 lots of 1 quintal is found to be 110. Sample size is 50, sample mean is 110. So second sentence itself gives two information. This is the information we are getting from the second sentence. N is equal to 50, MS is equal to, sample mean is equal to 110. Now last is test whether the quantity of waste increase. As per the question, alpha is equal to 0.01 level, means the test is to be made at 99% confidence level. The test is to be made at 99% confidence level. We are going to test whether the quantity of waste has increased. Whether the quantity of waste has increased. This is again one tail test, that is right tail test. Make note of it. This is a one tail test and a right tail test. You are going to test whether the quantity of waste has increased. Now, coming to standard error of mean. Those who have done it, kindly record the answer. Kindly make a comparison of your answer. Standard error of mean is 1.69. Our standard error of mean is found to be 1.69. Okay. Now, what is the Z value? Putting the formula, we will get Z is equal to 5.59. Z is equal to 5.59. Should I go to the next one? Fine. Now, what is the table value? At 0.01 level. At 0.01 level, the critical value should have been 2.58. But as it is a one-tail test, fine. One-tail test, the critical value is 2.81. This is what I have been getting from the table D. This is what I have been getting from table D, 2.81. So critical value is 2.81. The calculated value is 5.91. Here the calculated value we got in the previous slide. Got it? This is our calculated value, Z value. So we can say that Z calculated value 5.9 is greater than Z table value, that is critical value. Table value means critical value for one tail test at 0.01 level. Alpha is equal to 0.01, 2.81. So we can say that null hypothesis is rejected.
Why did you use table D and not table A as stated in the slide itself?
In that table, with respect to the degree of freedom, I cannot find out the p-value. There I will get 2.58 at 99% level of 90.01 level, 99% confidence level.
So if we use table A, you would have gotten 2.33 for the critical value, not 2.81. And
even though I will get 2.33, it will be less than that of the calculated value.
Yes.
And that is much less, not even at that.
Yes. And one question in general I have: when would you use the T distribution? Is it just for when n is less than 30, or is there any other criteria of using T distribution as opposed to normal distribution?
No, it depends upon the sample size. If the sample size is less than that of the 30, we should go for the T distribution. Because in that case, we are not getting a perfectly normal probability curve, perfectly normal distribution curve. We have a normal distribution curve. It is not perfectly normal distribution curve. So we can say that there is slight deviation of the, in T distribution, the normal distribution curve is slightly deviated. The normal curve we are getting is slightly deviated. It doesn't, it not exactly approaches, it is approaches towards the normality, but not exactly normal.
Another question I have: if you have a left tail test, and the Z value is less than the critical value for the left tail test, shouldn't you reject that value? Shouldn't the H0 be rejected, because then it'll be outside the range for a left tail test?
Could you please repeat it again?
You have a left tail test.
Yeah.
Right. So therefore, the rejection region should be on the left.
Yes.
So therefore, if the Z value is less than the critical value, you should reject H0, because that is the rejection region.
Yeah.
All right.
Yes,
so
yes, agree.
in number 8, you said that H0 was accepted, although the Z value was in the rejection region.
No, it is not. Which number?
Number 8. If you go back in the slides in number 8, you will see that.
What happened there?
You had a negative 7 point something. I have
7.67. 7.67.
Right.
Yeah.
Which is less than your critical value. So therefore it should reject.
Yes. See, minus 6.67, that is in the left side of the mean. Again, the critical value 0.05, 1.96 minus 1.96, that is also left side. So it is within the area of rejection. Minus 6.67 is a part of the area of rejection which is beyond minus 1.96. Both are minus value. Please make note of it. Both are minus value.
Yes.
So position of the minus 6.67 is left to the position of minus 1.96.
Yes, which would make it in the rejection region.
Yeah, that is a part within the rejection area. Beyond minus 1.96, that is the part of area of rejection. So here our Z value is a part of the point within the rejected area. Got it? So Z is minus 6.67 is smaller than Z minus 1.96. Or simply we can say that, I can say that minus 6.67 is smaller than minus 1.96. It is not 6.67. Please make note of it. It is minus 6.67.
Yes, sir.
Okay.
Excuse me, sir.
Yes, ma'am, please.
This particular one.
Yeah.
Where we use the Z table. I'm having difficulty to actually understand. 5.91 is greater than 2.81, and we reject it. When do we now? Is it because it is one tail test that we are now rejecting it? I don't understand.
No, simple logic I have used it here. Your calculated value is much more greater than that of the table value, critical value.
Yeah.
Our calculated value is 5.91. Our critical value is 2.81. So calculated value is greater than critical value. So if the calculated value is greater than critical value, so null hypothesis is rejected. We don't accept the null hypothesis. Had it been smaller, we should have accepted the null hypothesis.
Okay, if it's smaller, we accept.
Yes, if it would have smaller, we would have accepted the null.
Is it the same thing applicable to T table? That is when we use the degree of freedom. So when it is greater, we will reject.
No, ma'am. In both the case, we apply the same logic, whether it is T test or it is Z test. Only the process of finding the critical value is different. In case of the T test, we are using a degree of freedom n-1. Then we are referring to the table D. Then we are referring to the table D. Left-hand side column is giving degree of freedom. 14 we are identifying. Then we are going to the alpha value. Okay. In the horizontal column, we are saying the alpha value. In the vertical line, we are seeing the degree of freedom. So degree of freedom is in the horizontal line, and the vertical line we are getting the alpha value, where they will intersect each other. That is the critical value. So whether it is a T test or whether it is a Z test, only the finding the process of critical value is different, but the process of making analysis and interpretation and making analysis of the result is remains the same. If calculated value is greater than the critical value, always null hypothesis is rejected.
Okay.
Means the our value is within the area of rejection.
Yeah.
Our calculated value fall within the area of rejection.
Okay.
Okay. So we can interpret that average quantity of waste has been increased. This is what is the question number 9. Okay. Any other question from your end? If there, you are most welcome. I am ready to respond to you. So to my understanding, I have just touched upon all the questions. That is 2 check your progress question and 1 and 9 reflection questions. 9 reflection questions. So any question, basic questions, please ask. Then we will move to
sir.
Dr. Manas. Yeah.
Excuse me, sir.
Yes, ma'am, please.
Thank you very much for the lecture, for the discussion so far. About the assignment, sir. You know, we were asked to use our area of specialization. Does it mean we are going to change the question just to suit this number of samples, like in the assignment is given that N is 600 and the standard deviation? We will use the data as you have given us.
Yes.
Then we change whatever we want to change, but the data must be the same. Is it what you're talking?
Exactly, we want that one, madam.
Sir?
Exactly. You use those numbers.
Okay.
Prepare your own question.
It's okay, sir. It's okay.
You may take it from science, you may take it from mathematics, you may take it from English, you may take it from business, you may take it from agriculture, you may take it from tourism.
It's all right, sir.
So whatever area you can take it, but our request is to use those values.
Values, okay, sir.
Use those values. Yes. Okay. You may take a IQ level psychology from you can relate it to the psychology, or you can relate it to the critical analysis, or you can relate it to the any area, your choice. There is no restrictions of any kind.
Sir, how many questions? Only one?
Assignment, only one question, but there are 5 to 6 bits. You look into the assignment question that is given. There are only one question, but some bits are given. You are expected to use those bits. Okay.
Okay, sir.
Those who are there, do you
then
have
in the submission in okay, you have, there is a okay. This where to submit is written there. We use this.
I am requesting you not to get hurry for submission. You have enough time for submission. First prepare it, go through it again and again, revise it again and again, improve it. You will on 26th we will give you a demo. Then when we will show you the demo, you will get to know to what extent you have completed, what level of perfection you have achieved, what level of significance you can say that you have a very good assignment prepared. Then 27th, 28th, 29th, 30, 4 days are there in your hand, you can submit it. For submission, it will take 2 minutes. Don't worry, for submission, it will take 2 minutes. Once you submit, you cannot redo on it.
Thank you.
Okay, so please have patience, prepare it, improve it to the extent possible, so that after 26th make a submission, so that a level of confidence can be generated by your own to what level of confidence you have in preparing the assignment.
Thank you, sir.
Okay, so we will have another live session in 2nd December, where we will talk about questions of week 4. Questions of week 4.
Thank you for your presentation today, sir.
So now I would request Dr. Manas to kindly take up.
Sir, I wanted to ask one question.
Yes, please.
Sir, in question number 8, whether the null hypothesis is accepted or rejected, please confirm.
Question number? Please tell.
Question number 8, sir. Question number 8.
Null hypothesis is accepted.
Okay, sir.
Here we can say that the average weight of the gas cylinder is 15 kg. What is the question asked in the question? What was the question? Test at 0.05 level of significance that the average weight of the gas cylinder has less than 15 kg. Average weight of gas cylinder is 15 kg.
So question 8 is the left tail test I was asking you about, where it was outside the range. So it should be rejected.
Minus 6.67.
Yes, sir, that would be in the rejection range. Well, it is less than the critical region.
So we are not saying that what is the question? Please see, the average weight of the gas cylinder is less than 15 kg. Test, the average weight of the gas cylinder is less than 15 kg. In our interpretation, we are not saying that average weight is less than 15. But we are interpreting. We are 99% confident that average weight of gas cylinder is 15 kg. We are not saying it is less than 15 kg. Finally, we are reaching at a point based on our calculation that average weight of the gas cylinder is 15 kg.
Okay, sir. Thank you.
Now,
thank you very much, Dr. Das, and we are excellent discussion today, and I have seen that lot of queries, lot of discussions, and critical discussion, I can say, is happened this live session. And really, it is good that we could have continue for another few minutes, but the schedule is completing, and we exceeded 21 minutes. It's really nice interaction and engaging session. Thank you very much, Dr. Das. Thank you very much, all my colleagues and participants of this workshop. And thanks a lot. And I would like to request all of you, please complete your quiz and write also in the forum to helping your peer groups to complete their quizzes themselves. So please just you can write in the forum that, yes, I have completed my quiz. Please, my friends, you can also complete your quiz. All the 4 quizzes are open till the end of course. So please encourage your peer group and encourage your peer group to attend the live session to get benefited, which will be scheduled in 22nd and 26th respectively. And more we can speak about your assignment in upcoming sessions, as well as you will get a lot of help to complete your assignment and submit your assignment, so that maximum of your you and your peer groups will get a completion certificate. Not only just certificate has definitely some credit, but at the same time, the discussion which will happen, that will help you a lot in your professional engagement and professional development. So thank you very much joining with us and for this time, and have a nice day, and say bye bye right now and meet in the platform. Thank you very much. Thanks a lot. Stay safe.
Thank you, Dr.
Stay healthy.
Thanks to all participants.
Thank you very much, Dr. Das, for your nice time this evening. Thank you very much. Thanks a lot. Bye-bye.
Bye.
Bye.